In this video, I will be discussing one of the important decoupling technique of carbon-13 NMR spectra, that is broadband decoupling or proton noise decoupling. Before jumping into this video, we have to know some of the important features of carbon-13 NMR. See, the natural abundance of carbon-13 is only 1.08% of the total abundance of carbon, and hence very rare chance for carbon-13 nuclei to have another carbon-13 nuclei in the neighboring carbon atom in a carbon-carbon bond. And so there will be no possibility for homonuclear coupling between carbon-13 nuclei in a carbon-carbon bond. Okay, but there is a chance for heteronuclear coupling between carbon-13 with a hydrogen nuclei directly bonded to it, that is a CH coupling, C single bond H coupling. Signal of carbon-13 thus split into multiplet by this heteronuclear carbon-13 hydrogen nuclei coupling, that is CH coupling. In addition to it, there is every possibility for carbon-13 coupling with hydrogen nuclei of neighboring carbon atom, that is C single bond H coupling, CCH coupling, that is a two bond coupling. You know, the coupling constant in heteronuclear one bond coupling, CH coupling, is very large, so that the difference between chemical shift and coupling constant become very small. That is why the multiplets overlap each other, forming a very complex spectra. Okay, there are three decoupling techniques in carbon-13 spectra: the broadband decoupling or proton noise decoupling, off-resonance decoupling, and DEPT spectra. I have already made a video in DEPT spectra. You can watch the video of this DEPT spectra in my channel. Here I will discuss the broadband decoupling or proton noise decoupling technique. Okay, this decoupling technique eliminates all the interaction between the protons and carbon nuclei. As a result, only singlets are observed for each type of carbon atom in a proton decoupled carbon-13 NMR spectrum of a compound. Okay, although this technique simplifies the spectrum and avoid overlapping of multiplets, it has the disadvantage that the information regarding the attached proton is lost. That is why we cannot ascertain how many protons or how many hydrogen atoms are directly attached to the carbon atom. Okay, proton decoupling is done by simultaneously irradiating all the protons in the molecule with broad spectrum frequencies in the proper range. Irradiation causes the protons to become saturated, and they undergo rapid upward and downward transition among all their possible spin state. Thus, the rapid transition results in averaging of all the spin interaction to zero. The carbon nucleus experiences only one average spin state for the attached hydrogen atom. As a result, the spin-spin interaction between carbon-13 nucleus and hydrogen nuclei attached to it are decoupled. It is the process of broadband decoupling. Okay, see the proton coupled and decoupled carbon-13 NMR of ethyl phenyl acetate. The first one is highly complicated. It is proton coupled spectrum of ethyl phenyl acetate. We cannot define each of the signal because most of the signals are overlapped each other. But in the second case, it is the proton decoupled spectra or broadband decoupled spectrum of carbon-13 spectrum of ethyl phenyl acetate, where each of the signal is well defined. For example, it is of CH3 group, this CH3 group, and it is of CH2CO group, or carbon atom of CH2, this carbon atom of CH2CO group, and it is of carbon atom of OCH2 group, carbon atom of OCH2, this carbon atom, and all the aromatic carbon atom is concentrated here. There are 4 types of aromatic carbon atom. You can see these 2 and 6 are equivalent, 3 and 5 are equivalent, 4 is another type of carbon atom, and 1 is another type. So there are 4 sets of equivalent carbon atom, aromatic carbon atom. These are all concentrated in this region. It is of CO group, carbon atom of CO group of this molecule, CO group, this carbon atom of the molecule. And here you can see all are obtained as singlet, so that we can define very easily of the carbon-13 NMR. That is the important feature of broadband decoupling technique or proton noise decoupling. Okay, I hereby conclude this video. Thank you all.